If you're watching this video, you probably know the function FirstOrDefault from another programming language. Look at this list in C#. Lists in C# are generic and the type in the brackets specifies the element types. I call FirstOrDefault on the list and pass a predicate function. The predicate function returns true when a number is over 10. When the FirstOrDefault method found an element that satisfies the predicate, it returns it. But when I search for numbers over 50, no number is found and the integer default is returned. The FirstOrDefault method can do this because it knows the list element types. You can also do this for complex types like a custom class. Here is class employee that takes and stores an ID and name. I create a list of 3 employees and search for an employee with ID 2. And Carl was found. In case I search for an employee ID that does not exist, the object default is returned, which is null in C#. I have used the FirstOrDefault method millions of times when I used C#, so I wanted to know how to do this in Python. Here is a list of integers. I use a generator expression to filter all numbers over 10. I use the next function to get the first element from the generator. I print the number and execute the code. And that works, but this code has a problem when there are no numbers in the result. Python raises an error and this can be fixed by passing a default value to the next function. The default value for an integer is returned. Let me create another list with employee objects. Class employee takes and stores an employee ID and name. I search for an employee with ID 2. This should print the name Carl. And that works. Now I search for an ID that does not exist. And that returns none, as it should. If you are not interested in types, you are done at this point. These generator expressions are all you need to filter a list and get its first element or provide a default value. But perhaps you wonder, can't I let Python generate a default value without specifying it here explicitly? And you can. For this I will use type hints and generics in Python. But I have got to warn you. Type hints are in full motion in Python and it feels like every new version of Python adds and changes a lot of functionality. What I show you here works in Python 3.12, but there are no guarantees it will work the same way in a next version. The only thing I can say is that I hope it does, because what I will show you is very cool functionality in a dynamically typed language like Python. Are you ready? Here comes the magic. The first thing I do is subclass list and make it generic. I add method FirstOrDefault. When I instantiate the class, I pass a type. Now the Python interpreter will ignore the type info, and this list works just like any other list in Python. I can use the FirstOrDefault method like this. That works. When I search for a number over 50, FirstOrDefault should return 0. And that works as well. But notice I return literal 0 here. This will be a problem when I use the class with type string. Now the code will work fine. But now I add some type hints. The result type of this function will be t. I run a static type checker. A return type t is expected and is not compatible with the literal 0. I need to get the type info for t at runtime, and in Python 3.12 I can do it like this. Then I instantiate generic type instead of 0. I search for a name with length over 10. The search for numbers should result in default value 0, and for names in default value empty string. And that works. And now the type checker should also be satisfied. It is not. But that is not because of the type. This error is because Pyrite cannot find this dunder method. The problem is that getting the type info at runtime is experimental. I am not supposed to access this dunder method directly. But I am a bad boy and I will ignore the error. Looking good. I hope Python will add functionality to get the type info with an official API. For now, I have to use this experimental feature. As long as I am annotating, why not annotate all? The predicate is a function with parameter of type t and returns a bool. I import callable and run Pyrite again. Everything okay. This is a true generic method, but will it work with all types? I add class employee. I create a typed employee list. And search for Carl. An error. That is interesting. The generic type is now employee and cannot be instantiated without an ID and name. That makes sense, but I did not expect this code to be evaluated at all. No problem. I rearrange some things. I wrap the next function in a try block. And in case of a stop iteration error, I return the type default. Let me test that. That is better, but you already know I will get the error again when the employee cannot be found. This time the error makes sense. The employee could not be found and also not instantiated. For this case, I add an extra try block. And in case the default value cannot be created without arguments, I return none. And now I get the expected result. But is the type checker still happy? Nope. The function promises to return t, but it can also return none. I make t optional. I import optional and try again. And now everything works. Let me search for Bill. Very good. That was quite a puzzle. Yes, type hints add more code and runtime generics are still experimental, but they are a cool feature. And if you want to see more generics in Python, click on this video right now. There you get more ideas where to use generic classes in your projects.